find all the answers, whether they are real or complex. To find the zeros means the places where y is 0, the x-intercepts. When I look at this polynomial, I cannot factor it. And if it's not factorable, I'll use the rational zeros theorem, where p comes from the constant at the back, q comes from the leading coefficient at the front. We're going to consider the factors of 25 as compared with the factors of 1. Well, that's nice. So we're not going to be dealing with fractions. The factors could be 1 and 25, or 5 and 5. Positive or negative. We're not sure what to try, but let's just start trying 1. If it doesn't work, we'll try negative 1. Let's copy our coefficients. 1, negative 9, 33, negative 25. All terms are represented. We're going to divide by 1 because we want to know if 1 is an answer. Bring this down. 1 times 1 is 1 on the side. Negative 9 and 1 is negative 8. 1 times negative 8 on the side. 33 take away 8. 1 times 25. It is, oh, look at that. Oh, it's good. That tells us that x equals 1 is one of the answers. Let's not forget it. We're looking for 3. We just found one of them. 2 more to go. Write this as a polynomial. That's no remainder. 25 is the constant. Negative 8x and 1x squared. Say it again. That's x squared minus 8x and a positive 25. Okay. Now we would solve this by factoring, but the factors of 25 do not add to make 8. It's not factorable. You know what to do. There was the negative boy who was uncertain if he should go to the radical party because he was a square and missed out on 4 awesome chicks who was all over at 2 a.m. Where a is 1 in front of x squared, b is negative 8 in front of x, and c is the constant 25. So, x is going to be the opposite of negative 8, plus or minus the square root of the square of negative 8. Take away 4 times a times c, and it's all over 2 times a. Let's clean that up. That is 8 plus or minus 64, take away 100, all over 2. That's the same as 8 plus or minus the square root of negative 36, all over 2, which is 8 plus or minus 6i, all over 2. We'll simplify that. 8 plus or minus 6i over 2, that's the same as 8 divided by 2, and 6i divided by 2. So we have 2 complex answers. Altogether, we got a real answer 1. We have a complex answer of 4 plus 3i, and the complex conjugate 4 minus 3i. We found all zeros.